Hello everyone, my name is Yuken, and today we are going to talk about how we can draw the finite state machine for a Turing machine in a simple way. Right, so let us take a look at this question here. Draw the FSM for a Turing machine that accepts any string that contains 101. Right, so the main point here is that we want to find any string that contains any string that contains 101. So we have three different values in sequence 101, and then because we are talking about FSM, right, in FSM we are dealing with states, we are dealing with transition, and then when we are writing the transition, usually we will follow this format. We are going to read a value, and then we are going to write a value, and then we want to move from one state to another. Alright, so if we want to find any string that contains 101 here, so we need to have at least from somewhere transition to here, and then we get the value 1, and then from here to the second state we're getting a 0, and then from 0 transition to another state, and then we get 1 again. So here, if we are having 3 values, we need to have at least 3 states as well. 3 states here, and then 1 state here, and then we have 1 state here. And then don't forget that for FSM we need to start from somewhere, so we need to have an initial state here, and then we need to have an ending here. Alright, so let's just say that this is Q1, which is our initial state. From Q1 transition to Q2, Q2 transition to Q3, alright, from Q3 to Q4, from Q4 to Q5. Alright, so for Q1 initial states, usually we start reading the values from a blank value. So blank value is a box, alright, or a blank, which we usually just call it B. Alright, so for the best case, we want to move from the initial state to the next state. Right, it doesn't really matter the value, so it can be anything, but for this case, let's just say that we start from a blank. Let's just say that we start from a blank. Then in this kind of situation, the transition can be defined as we are reading a blank, and then next we want to write a value. Right, there's no need for us to change the value here, so we will just keep it the same. We read the blank value, and then we want to write the blank value, and then we want to move from Q1 to Q2. Alright, so let us just call it R. So we are moving towards the right hand side from Q1 to Q2. Alright, so starting from Q2, right, in order for us to move forward from Q2 to Q3, for the best case, we want to read the value 1. Right, for the best case, we want to read the value 1. So we want to read value 1, and then we want to write the value 1, and then we want to move on to the next state. Let's just put it R, move to the right hand side. So from Q2 to Q3. And now that we are at Q3, the best case is that we are reading the value 0 because we want to get 101. So for this case, like I said, for the best case, we are reading 0, then we are writing the 0, and then next we are going to move to the next state, which is Q4. And then Q4, which is here, we are expecting to get 1 for the best case, so that we can get 101. So here, we are expecting to read a 1, and then we want to write the value 1 as well, and then we want to move towards the right side so that we can transition from Q4 to Q5. So as you can see, starting from Q1, we are reading a blank value, and then starting from Q1, we move to the Q2. For Q2, we are getting 1. Q2 to Q3, we are getting 0. For Q3 to Q4, and then we are reading 1. And then last but not least, move to Q5. So in this sequence, we can get 1 here, 0 here, and then 1 here again. So gets 101. But of course, this is the best case. What happens if we are not getting 101? So for example here, we can get 0 instead of 1, because here we are talking about reading value 1 here. but that is the best case. We can also get 0 at this point. We can also get a 0. So if we are getting a 0, what we need to do is that we want to keep it at Q2 until it finds the value 1. So we can just loop it back like this. We can just loop it back for Q2, back to Q2, and then this is for the situation where we are reading the value 0, then we are writing the value 0 again, and then we move to the next state, the R. So right, so when we're talking about moving to the next state, it can be Q2 back to Q2 itself, right? So we are looping back Q2. So let's test this out. Let's test this out. So if we are getting 0, so we are looping back. So as you can see, we are talking about Q2, and then if the next value we are getting 0 again, then we are going to repeat at Q2 again until we find the value 1. If we find the value 1, then if we fulfills this condition, then we can transition from Q2 to Q3. Right? So we are getting the value 1. So now that we are getting 1, we can move to Q3. So if we're getting 1, we can move to Q3. And then we are going to read the value. Alright, so at Q3, at this point at Q3, we already have the 1. So the best case is to get 0, but what if we are getting 1 here? What if we are getting 1? So instead of 1, 0, we are getting 1, 1. So if we're getting 1, what we can do is that we can loop it back to the previous state. So for example, we can loop it back here, Q3, back to Q3, if we are getting the value 1. 1, we are reading 1, we are writing 1, and then we are moving towards the next state. So 1, 1R, we loop back to Q3. Alright, is it correct? So let's test this out. So imagine that we are getting 0, 0, we are getting 1 at Q2, we are getting 1 at Q2 here. Alright, let's just say that we are getting 1 at Q2, then we move to Q3. We move to Q3. So if we are getting 1, then we are going to repeat at Q3 again, and then 1 again, and then if the next value we are getting 0 at Q3, if we are getting 0, which fulfills this transition condition, then we can move on to Q4. Right? If we are getting 0, then we move on to Q4, and then double check. We have 1 here, we still have 0 here, which is true because we are expecting to find 1, 0, 1, and then we already have 1, we have 0, and then starting from Q4, the best case is that we are getting 1 so that we can transition to Q5. But what if we are getting a 0? What if you are getting a 0? So similar to the previous one, we are going to loop it back. The question here is that loop it back to where? Is it going back to Q4? Right? Is it going to Q4? Right? Let's test this out. If we loop it back to Q4, what will happen? Imagine that we're getting 0, and then getting 0, and then move to the next state. Right? What will happen here is that if we are getting 0, we loop it back 0, we loop it back 0 until we find a 1. Until we find a 1, right, which is here, then we move to Q5, and then that is basically the end state. Is this 1, 0, 1? No, we are actually getting 0, 0, 0, 1. So this is not 1, 0, 1. So we cannot loop it back. We cannot loop it back. So this is incorrect. So let us undo here. How about going back to Q3? Alright, how about going back to Q3? Is it Q3? So if we move back to Q3, from Q4 to Q3, okay, so this is like 0, 0, R. So if we are getting 0 here, and then move back to Q3, if we are now at Q3, if we are getting the value 0, if you are getting the value 0 here, if you are getting a 0 here, then it fulfills this transition condition, then it moves to Q4, then it moves to Q4. It doesn't really matter if you are getting 1, it doesn't really matter we are getting 0, because no matter what, it doesn't fulfill the condition of having 1, 0, 1. So transition back to Q3 is not really appropriate. Even though if we are transitioning back to Q3, if we get 1, then maybe we can still get another loop Q3 to get 0 again. But because we have the possibility of getting it wrongly here, so we cannot loop it back to Q3 again. Then we have to find another path. So we cannot loop it back to Q4. We cannot change it to Q3, transition to Q3. What we can do is that we can transition to Q2. So from here, we can transition from here to Q2. Right? If we transition to Q2, if we are getting 0, alright, if we're getting 0, let's try it out. If we get a 0 here, then we will move back to Q2. Move back to Q2. Right? Moving back to Q2. If we are getting 0, then we loop. If we are getting 1, then we transition to Q3. We transition to Q3. Oh, let me just grab some of the text here. Right here. Okay, let me just move this here. Okay, so for Q4 we are getting 0. Right, then we transition to Q2. If we are getting 0 again, then we loop through again until we find the 1. If we are getting 1, we transition to Q3 because of this transition condition. Yes, we are now at Q3. If we are getting 1, then we are going to loop it again until we get 0, until we find Q3 0. If you are getting 0, then we are fulfilling this condition. Then we can transition to Q4. Now we are moving to Q4. So at Q4, if we are getting 0, then we loop it back to Q2, which repeats the whole process. But if we are getting 1, then we can transition to Q5. Right, then we can transition to Q5. So here, if you take a look at this, we have 1, we have 0, we have 1, which is correct. And then if we are getting 0, then we start over from Q2. Just like here, we get 0 for Q4, we start over for Q2, and then go through Q3 again, go to Q4 again, until we get the correct answer. So this is the FSM for the Turing machine, so that it can accept any string that contains 101. So this is the structure. For Q1, we have the BBR, and then to Q2, and then we have two options. If it's 00R, we loop it back, or if we're getting 11R, we transition to Q3, and then it's going to be the same. If it's 11R, we loop it back. If it's 0, we transition to Q4. For Q4, if you are getting 0, we transition to Q2, else we transition to Q5. Right, so let's implement this and see how it really looks like. So starting from Q1, right, let's just say that the head starts from this blank here, Of course, for the head, it can be anywhere else, but let's just assume that we are starting from this blank. So let's just say that we are reading the blank, we are going to write blank, and then we are going to move to the next state, which is Q2. At this point, we are getting 0. Like I said just now, if we are getting 0 instead of 1, we are going to loop it back to Q2 until it finds the value 1. So we are going to loop it back, right? 00R, loop it back until it finds the value 1. If it finds the value 1, it transitions to Q3. And then for Q3, we are expecting 0. But if you are getting 1, we are going to loop it back to itself, which is like this, until we find the value 0, because we want it to have 1, 0, 1. So now we are getting the 0 here. We can transition to the next state, which is Q4. Now for Q4, we are expecting 1, but we are getting 0 right now. If we are getting 0, we are going to transition back to Q2, like I mentioned just now. Transition back to Q2. So now we are at Q2. So we are going to repeat the whole process again. So Q2, we are getting 1. So we already have this transition 1R, which will move from Q2 to Q3. And then now at Q3, we are getting 0. If it's 0, we will transition to Q4, which is correct so far. So now that we are at Q4, we are reading the value 1. If we are reading the value 1, then you will be transitioning towards Q5, which is the end. So this would be the final answer for the finite state machine. So as a conclusion, when you're trying to draw the finite state machine, you need to identify the requirements. So for example, this one, we want to have the string to contain 101. So we are dealing with 3 values, 1, 0, and 1 in a sequence. Then it means that we need to have at least 3 states. For example, here we need to have Q2, Q3, Q4, and then we also need to have the initial stage, which is Q1. We need to have the end stage, which is Q5. Total up, we are getting 5 states here, and then we can define the transition for the best case first. Only then we fill in the blank for the not the best case, like 00R when we are expecting 1, and so on. So basically this sums up the way for you to draw the finite state machine. Thank you very much.